So the purpose of this review is to go over the user interface and what the major features are of the oscilloscope that I have today versus what I planned, and just to kind of get some feedback on that. We'll start by going through what a basic display looks like. Up here at the top we got just date and time, no big deal there. We have a status here in the upper left hand corner. It says armed, it might say trigger, it might say hold. And then we have the vertical axis. In this case it's plus or minus 5 volts, so that's the total range. And along the x-axis or time axis we have 0 milliseconds to 50 milliseconds, so that's the scale across the x-axis. We have two cursors. This cursor would typically be blinking yellow versus it'd be clear. That's the active cursor, so if you did right or left it would be moving that cursor. The left hand cursor readouts are down here on the left hand side. The right hand cursor is over here a little bit more towards the center, but right of the left ones. And then we have a delta set down here, which is the difference of voltage between the two cursors, the difference in time between the two cursors, and then you take that time and you invert it and you get roughly the frequency that is represented by the delta t in those two cursors. In addition to that, we have this green bar and solid black bar. Those may or may not be there depending on what you've done. This indicates that you have zoomed in along the time axis to some extent, and this is showing you that this waveform that you're looking at right now is represented by this green out of the total width. So roughly you're looking at half the data. It'll be more obvious when I zoom in and you see it. To zoom in and out you use a chord. You use shift and right arrow to zoom in, shift and left arrow to zoom back out again. This bar in the upper right hand corner may or may not be there depending on how you have things set up. This indicates that you have averaging selected, and you've selected 16 averages, and this average can be either set up to be kind of like a fixed length where you do 16 averages and stop, and then you would be done. And when you hit 16, which is like this has got 16 because it's fully green, this would have changed from arm to hold if it was a linear fixed average. But I have a running average, so I've got 16, but I continue to collect data, and you'll see this little white dash kind of zoom across here periodically as it's continuing to collect data. And then finally down here in the bottom right hand side we have an SD card icon. Solid green indicates that the SD card is there, it's present, and it's mounted. It's really what the lock indicator indicates, that the actual drive is mounted and you shouldn't physically remove it. If you do remove it, there's always a finite chance you could get a corrupted card. Pretty low, but nonetheless it's possible. So you would typically use a menu item and select it to say I want to remove the card, and then there'd be some indication of that. This indication of a battery here. The battery's pretty low. The plus means that it's connected to a USB at the moment and we're charging the battery. And this little field right here toggles between voltage, temperature, and state of charge. So I have a temperature sensor close to the battery so I can monitor the battery's temperature. So with that, I'm going to switch over to a video where you can see kind of some of this stuff in action. Quick note about the video that follows. There's some quirkiness on the video. I'm not quite sure why that happened. It's not associated with the display on the instrument itself. That's all crisp and clean. So just ignore that's going on in the video.
Unit comes up and it displays something like this. You can see we have two cursors on the screen. The active cursor is the one that's blinking yellow, and the readout for the active cursor is down here in this corner. It's 187 millivolts at 5.6 milliseconds. We can change cursors, so that's that readout over here is the second cursor. And then we have the delta between the two cursors. that are down here showing 545 or 49 millivolts difference, 1.39 milliseconds, which equates to about 714 hertz. Obviously, you can move the cursors, and you can toggle them back and forth as to which one you want to look at. Now, in addition, this is intended to be a dual channel scope, so you can select the layout. And when you select the layout, it shows you the layout that you have at the moment, which is just waveform A. You can pick waveform B, waveform A over B 50-50 split. Same with a 66-34 split or a 34-66 split. I don't have much on waveform B at the moment, but at any rate, let me pull that back up. Show you the split. We'll just go with this one. So on the top we have a waveform A, and on the bottom we have waveform B. We can switch cursors to go down to B, switch cursor to the other one, and make that go down to B as well. So now we're on the B graph as opposed to the A graph. And very quickly we can go back the other way as well. For this demo, I'm just going to really talk about waveform A only, because my prototype board doesn't have much support for waveform B yet. Down in this corner, we have a battery indicator. The plus means that it's plugged into the USB, so it's charging. It shows a little icon for the SD card that it's present and it's locked. If you want to remove the SD card, you pick SD card eject. There's no second chance on that. You just pick it and you're done. And the block goes away and it's blinking saying you need to remove the card. I'm removing the card and it clears. And when I plug the card back in, it'll pop back up again. So for trigger run, you may notice in the upper right hand corner there's a bar graph here. It's got averaging enabled with 64 averages. And when I pick run, it'll start averaging that data, collecting data and averaging it. So in a moment here, we'll have 64 waveforms in this set. And I have a running average selected, so you can see there's a little dash mark going through here. So we're continually updating this graph. If I was to disconnect the input, the scope probe, which I'm doing now, you'll see that that waveform begins to decay back down again because it's not measuring anything. And I'll plug it back in, and it'll start building that waveform back up again. At any point in time, you can hit hold, and it will stop. You hit run, and it restarts and builds all over it. You can hit hold in the middle, and we got, I don't know, maybe 8 out of the 64 waveforms in that data set. You can come down here, and in addition to layout, you have settings. And under settings, you have channel A. You can pick AC versus DC coupling. The external probe being 1x or 10x. The range selection, I'm not quite sure why it's on that. I would have expected that I would have maybe on auto range and let it pick the range. And on each of the channels, we are sampling oftentimes way over sampling compared to what the waveform is that you're displaying. Well, when you have that, you can either apply a low pass filter when we rate decimate from, let's say, a megahertz down to, a few hundred kilohertz or something, depending on what you got. So you can turn this filter on and off. And then when you're done and you either don't like what you did, you can hit cancel or you can hit accept. You have a similar layout for channel B. And you now have trigger setup. For trigger setup, you have auto or single. Single is just what you might expect. You hit arm on it, it collects one waveform and it stops and holds and waits for you to tell it to go again. Auto is it just repeatedly collects data until it either hits the averaging spec that you put, or if you want running some, it'll continue forever. And then under trigger source, you can pick free run, meaning no trigger, channel A, channel B, or external. At the moment, I don't have support for external. Trigger slope, positive or negative. This is what I'd recommend. You can use auto level hysteresis. So I look at the waveforms that I'm collecting and figure out what an appropriate threshold and hysteresis would be. If you don't want that, then you can pick no, and those other fields become on grayed out, that you can specify the trigger level, whether it's a positive or negative level, what percentage of that screen full scale value that you want for the trigger level, the hysteresis level. You can pick a hysteresis from 0.1% up to 20%. And the amount of pre-trigger. You can hit pre-trigger from 0, 10, 20, 50, 90. So for instance, if I pick a 20% pre-trigger, and we'll just continue to use auto just because it's easy, you don't have to think. And we come down and we accept that. And we tell it to go. Whoops, so we gotta back out of that screen and tell it to run. So you see a vertical line here. That indicates where the actual trigger is. So 20% of the data was collected before the trigger, and the other 80% was collected after the trigger. So you can select up to 90% pre-trigger. Continuing on settings, you have waveform. For waveform, you can pick the time base that you're going to see for your time waveform, anywhere from 5 milliseconds up to 1 second. And for instance, if I pick 1 second and tell it to go, it's a 100 hertz signal over 1 second, so we're really collecting 100 cycles. But we can zoom in on that and look at this because there's really a couple thousand points underlying this. So here's the maximum zoom in. There's a little bar graph at the top here, that little green out of that big black line that shows you what percentage of the waveform you're really zoomed in to look at. And when you zoom in, it zooms in centered about the active cursor. So you'll see the active cursors in the center of the display. Of course, you can zoom back out again. So if I move the active cursor, let's say I'll just move it down to close to where the pre-trigger is, and now zoom in, and it'll be close to where the pre-trigger line was. And if you zoom in enough, it'll move that other cursor in off from that border over here. It would have been off screen. If you zoom in enough, it'll bring that other cursor in, so that other cursor always remains on screen. Again, continuing on waveform, let's see, we did, when you pick the time span, and then you can pick the number of averages, anywhere from none to 2, 4, 8, 16, 32. We can just pick 16 just for being different. And then instead of running, you can do linear, meaning I'm going to collect 16 waveforms, average those together, and then stop, as opposed to continuing to run forever with an exponential weighting. So if I accept that, we start the collection all over again, and we will collect, once we get to 16 of these, then we will stop, and it's the trigger status in the upper left corner here will go from trigger armed to hold once we reach the 16 averages, and then we are at hold at this point. And now the little dash mark in this green bar is no longer active. And then under general, you have inactivity timeout for shutting off the power. You can set it for 15 minutes, 1 hour, 4 hours, 16 hours. 16 hours, unless you're trying to collect some really rare event, you probably would use that only if you're doing charging the battery. If you're charging the battery, I only charge it when the unit's on, because I'm monitoring the battery's temperature and controlling what percentage of a charge I'm doing. So the unit needs to be on for that to work. It will shut off after a certain amount of time once it hits 100% state of charge, and this inactivity time. A screensaver delay. So this display is subject to a burn image. So after 5 minutes, I start throwing up text that moves around the screen. And you can set this anywhere from a few minutes up to an hour. And then in addition to that, if it's just sitting there and there's no user activity, I do dim the screen even before the screensaver kicks in. I haven't really fleshed this out, but I intend to support a couple different color palettes. This is the bright palette, if you will, because it's a bright white background. My intent is to have a dark palette, although I don't really have it much implemented. You can see the border kind of went dark around the outside, but the screen itself is still white. Again, I haven't done much with that. And my intent is to have kind of a classic, which is a phosphorescent type color like you might see on a CRT from the 50s or 60s. And you can set the date and time. It's already set, so there's not a lot you have to do, but you can navigate around there, change the up or down arrows to change the year, month, day, whatever, and then you can accept or reject, which in this case I'm going to cancel. And then is a, oh yeah, print screen. You can do a shift enter to get to print screen, so that's kind of a chord in order to do that. And it came up and told you that the print screen was success, and it told you the file name. Whenever you do a print screen, it puts it under a folder with today's date on it as the folder name. So you can collect waveforms today and go tomorrow, and then you can figure out where to look for them. When you have these pop-up screens like what's on the screen right now, you just hit the enter button to exit because there's no dialog button itself. And there's a power off. If you pick it, you do get confirmation on that to say cancel or yes, either one. I'm going to hit cancel. There's a different way to homage to Microsoft. There's a 3-button salute. If you hit the right, left, and up arrows simultaneously, it will reboot, and it reboots through an assert, just as the way of testing the assert. So it's telling you that there was a fatal assert. It gives you the file name, which is IO expansion module, which is where the 3-finger salute was detected. I'm at line 216. So there are asserts sprinkled throughout the code. So if you get one, this is the type of thing you would see pop up. Again, you hit enter to dismiss that, or you could, maybe more typically a developer would hit shift enter to print screen that. So now I have a print screen of the fatal assert with the line number and file name. That's pretty much it. We'll shut the unit off and done.
So just as a wrap up, I'll show you those 2 print screens we did. Here was the first one, and let's see if we can get the second one to pop up there. And here was the second one with the fatal assert. So if you have any comments, please let me know. I know there's one that I really struggle with, which is that average. I'm using running average versus linear, and I'm kind of mixing the terms. So one running is really an exponential average versus the linear average. So there's something wrong with that terminology I have to fix there. Maybe you have some comments on that. Again, thanks for watching. Bye.